Good. Thank you very much. Well, thank you, everybody, for the invitation to be with you. It must be nice to get out of the cold and into somewhere warm where you got a chance for a bit of shut-eye. You have to admit that the importance of geological pigments must come as no surprise when you consider the beauty of nature's palette, really, here in this mainly tertiary and quaternary sequence in the Vinicunca Mountains, just outside Cusco in Peru. I'm always a little bit suspicious of some of these images that they might have been enhanced, but nevertheless, even with enhancing, they're absolutely beautiful. These rainbows of colours are due to the chemical contents of different rock types, which range from greenish phyllites through to the whites, reds, yellows and browns of various sedimentary rocks. And we've got a few others here, look, some from the Salt Dome in Iran. The colours here are actually due to thermophilic algae and bacteria, but associated with a geyser, and petrified national forests. Some of you may have been there, with the agatized wood that you can see there. And a few sequences here from the late Cretaceous of Argentina. And just finally, some rock formations from China. I might just well leave it there, really, because the art is done, isn't it? Well, actually, I'm amazed that I'm here talking to you about this topic because, well, you've heard that I'm a vertebrate paleontologist and not a mineralogist. So that's one thing to hold against me. But also when it comes to art, I'm an absolute Philistine because the first subject I dropped at school was art. And the second one that quickly followed was history. So I hope you appreciate that I've overcome my natural antipathy to both of these subjects this evening to be able to bring you something about art. Well, the next problem is what to include in this lecture and what to omit. For example, should I include minerals such as these decorative stones, as in this 15th century to 16th century mosaic mask of one of the Aztec gods, a name I can't pronounce, where pyrite, look, is used to fashion the eyes, and the face was made of alternating bands of lignite and turquoise. And what about stones used for the purposes of sculpture, such as the famous Italian Carrara marble, utilized by Michelangelo in his famous Pieta, as we've got here? And then there's the enormous diversity of the precious and semi-precious stones that were used to produce beautiful effects seen in tabletops and panels of pietra dure. Hard stones carved into shapes and inlaid into a solid base and still being produced today. And then there's also the whole question about the clay mineralogy of pottery and the chromium-based pigments used to produce the famous Chinese blue porcelain. And also then there's the lovely images of geological materials imprinted and other records on paper, such as this plate from the Paper Museum of Cassiano del Pozzo in the Royal Collection. Well, I've elected to ignore all those and other applications of minerals in artistic contexts in order to concentrate on the use of minerals in painting. Now, does this image hold any memories for you? I seem to get one of these most years as a Christmas present, and given my hatred of art, you can imagine my joy at opening the stocking and finding this in the bottom there. I absolutely hated them. I didn't take to painting at all, and secondly, they always turned into a complete mess at the first time of using. But nevertheless, exactly the same things as that roundy one are known from Egyptian deposits. So things don't change very much, do they? I do remember being fascinated by the names of individual colours, though, and wondering how on earth they came up with such seemingly nonsensical terms as scarlet lake, burnt umber, raw sienna, and rose madder. And now I realise that there's a logical, albeit archaic, system of nomenclature at work here, with the older names being preserved as art evolved. It's a bit like geology, really, because exactly the same has happened in our science. And to put you out of your misery, the lakes were organic pigments mostly derived from plants, whose colours fastness was rather poor, and on exposure to light, they tended to fade. They were fugitive colours. Next, the question arises as to how we know what types of pigment were actually used in painting. Well, for Renaissance and early modern paintings, we're fortunate enough to have several manuals on the production and preparation and uses of natural pigments. The most famous of these is by the late 14th and early 15th century Italian artist Cennino Cennini, a student of Giotto. Another clue lies in the survival of contemporary examples of unused pigments. Here, for example, is Van Gogh's palette, complete with paints as preserved. You can just imagine dashing out the room for a cup of tea and not coming back again. And then there's also this set of painting equipment, basalt grinder, a grinding stone, palettes and brushes of various types, excavated from Thebes. And I think I've been here before talking about my interest in the uses of geological materials in medicine. And during my search for examples of geological medicines, I had the opportunity to study a Materia Medica cabinet in Cambridge. And amongst the drawers there were some authentic contemporary pigments from 1705, still in their brilliant hues there. And I've labelled up the ones that are based on mineralogical materials. Well, conservation of paintings also is necessary, and it's an ongoing project which benefits from the use of a wide range of imaging and analytical techniques, some of which are listed here. And a very useful database of pigment types and identifiers is being produced, aiding the identification of sources of individual colours on many paintings. Perhaps we should also briefly mention the qualitative characteristics of the colours which the pigments are used to produce. And these include the lightness, the hue, and the saturation of the colour, which I think pretty much speak for themselves. And then there's the consideration of how the pigments should be applied to the canvas or the board. Firstly, a binding medium is needed as a vehicle to apply the pigment and to hold the pigment particles in place. In medieval Renaissance painting, this was normally egg tempera, which basically is just egg yolk. The disadvantage of that material is that it dries up very quickly, so that the artist has got very little control over it. And it has to be mixed and used when needed and then put on pretty quickly. This also meant that the blending of different pigments together to produce a bigger range of palette was going to be problematic as well, because everything had gone off before you had a chance to mix everything together. So the introduction of oils such as linseed, walnut or poppy oil permitted easier blending of different pigments and the production of a wider range of tones and opacities, allowing the artist to develop shades and rich colours and give a more glossy finish. Drying time was slower and could be modified further by different additives, as we shall see. The oil paints could also be stored ready-made, adding to their versatility. Finally, we should also consider the different qualities of certain pigments. I seem to have lost a slide. Let me just... Oh, no, I haven't. Perhaps I've put this in the wrong place then. Let me go on to drying then. Well, it says here, as you can see, that oils are complex mixtures, really, of different chemicals, especially when you consider the different sorts of binding agents that they were used. And this meant to say that the various pigments, when they were bound into this oily matrix, because drying time was so slow, they tended to react with each other and give different colours to what the artist was expecting. So that meant to say that a series of drying agents was introduced, and these are called secatives, and that meant to say that the artist then had a bit more control over drying time and therefore on the appearance of the colours. And you can see that there were various approaches to this, one of which was to use resins, which oxidize nice and quickly, and so that they would, because they take the oxygen uptake is quite quick, that means to say that any alteration in colour takes place mostly before you apply the paint to the palette. But a better approach and a more universally used approach was to use different minerals. For example, litharge, lead oxide, usually a weathering product of lead ores such as galena, and not generally available in enormous quantities, but that acted as one dyeing agent. Another one was massicot, which is just a dimorph of litharge, so slightly different color of lead oxide. Again, a weathering product, mostly coming from various mountains in Germany, and that could be used, mixed in as well. And more easily, there's this quote here: if you want to varnish to dry quickly, add 3 quints of finely bound bright lead oxide, massicotte, to it, and when it's well boiled, let it cool and sieve it through the cloth and keep the varnish clean, and it'll be good for use. So says a German manuscript from 1510. Well, alunite is rather more easily obtained. It's a hydrated potassium sulfate, and a 14th century manuscript says that you should, if you want to make gold paint, take varnish and alum and linseed oil, boil everything together. If it becomes too thick, add more oil. If it becomes too thin, add more alum. It seems like a very sensible process to me. And then there's goslerite. Have you heard of these minerals? Anybody come across massicotte before? Goslerite? No? Well, this is an education in mineralogy as well as art then. So goslerite is named from the closest town from which it was manufactured, or dug up, I should say, from in Germany. It actually comes from a small village called Rammelberg. And this was the sort of world supply of goslerite at the time, but there were vast quantities there, and it flooded the market. It was the drying agent of choice for Renaissance artists. Perhaps the easiest of all, though, is to use pumice, of course, highly vesicular, extrusive igneous volcanic glass. And again, we got a manuscript comment here from the 1400s. One should take as much as one wants of linseed oil or hemp oil or old nut oil, put old white calcined bones into it and as much pumice, and let them boil into the oil, and therefore you can adjust the drying time. So there's the qualities of the pigment. So there's the chroma, basically the color. The grain size of the pigment's important. That has an effect on the opacity, the amount of light going through it. The stability of the pigment, because you want it to be able to maintain the color that you expected for hundreds of years, preferably. The light fastness, basically saying that it won't fade when it's exposed to sunlight, and the potential for mixing with other pigments, especially if there's any danger of interaction between 2 different pigments. And the problem of light fastness is illustrated here. This is a painting by Edward Hopper, quite a famous one, and he didn't intend for the trees to be blue when he originally painted it. The problem is that he used a green pigment which wasn't light fast, and that meant to say that the trees altered in colour since then, and the lady's dress, although it looked perfectly reasonable, that colour, has degenerated from its original green colour. Well, the first mineral pigment we'll consider is the native mineral graphite. The crystalline form of the element carbon, of course, which consists of stacked layers of graphene. And the pioneering mineralogist Abraham Gottlob Werner coined the name graphite in 1789. Up to that point, there was an enormous amount of confusion about the identities of minerals referred to collectively as lead. All of them were soft and black, but chemical analysis in the 1770s, when the chemical revolution was just starting, indicated that they could be separated into several different types. For example, of these varieties of lead, one was molybdenum based, one of them was based on galena, which of course is a lead mineral, and then there's what later became known as graphite as well. Graphite mostly occurs in volcanic and metamorphic provinces, usually produced by the reduction of sedimentary carbon, and its black streak is the thing that's significant for us. An older name which seems to have been applied to the mineral is plumbago, or black lead, usually found in a massive form. Sometime before 1565, sources vary a little bit on this, some people say as early as 1500, an enormous deposit of graphite, locally called wad, was discovered at Seathwaite in Borrowdale parish in Cumbria, and the locals found it useful for marking their sheep. During the reign of Elizabeth I, Borrowdale graphite was used as a refractory material to line the moulds that were used to make cannonballs. The reason is that the graphite gave a smooth surface so that when you cast the cannonball inside, you had a beautifully smooth surface to the cannonball. That meant less friction so that the cannonball would travel further and could be propelled more accurately. So because of this usefulness, immediately the Queen sort of put her fingers on all of the graphite deposits that they could find. They became controlled by the Crown and, of course, therefore, subject to taxes. Well, plumbago drawings are graphite drawings from the 17th and 18th centuries. And there was a group of artists whose work in plumbago is remarkable for their portraits drawn with finely pointed pieces of graphite, usually on vellum. And these works were initially prepared as the basis of an engraving. Eventually, they would be produced as works of art in their own right, and even earlier miniature painters, such as Nicholas Hilliard, whom you might have come across. He did lots of wonderful pieces on Raleigh, for example, and Elizabeth I. He often used it in preparation of his designs for jewels and that sort of thing. Well, the preparation of pigments might have been involved a whole series of operations, the initial phase of which involved pulverization. Depictions of artists' workshop commonly indicate the presence of a support worker actively grinding the mineral material into a fine powder, as you can see here on the right. And the equipment used for this process is quite simple and changed very little through history. This is an Egyptian grinding slab and grinding stone showing the typical cartouche-shaped depression in the center in which the pigment was ground up. And this 17th century German paint maker is using a flat stone instead, as was very common in the 18th century. As you got here, he's getting a bit distracted from his work, I must say, by that young lady, but basically he's got a flat slab that he's using there. And here, note that a woman is grinding the paint in this particular example over on the right-hand side. Well, mass production of paints during the 19th century is captured here in a painting by Turner. Horse and donkey mills were seen, as we got here in the background, were used for grinding large quantities of cheap pigments, such as the ochres, the siennas, and the umbers, and used by decorators and artists. And the colourmen, as they were called, in fact, this particular one is grinding a red ochre, quite probably produced from that mill at the back and being forced around by the donkey. In Giovanni Battista Quadrone's witty "Every opportunity is good" here, we've given a detailed look at the painter's paraphernalia. Now, you can't see much of it there, so we'll zoom in a little bit, as you can see there. And that includes some innovations. They include several paint bladders on the table, because that's what the oil paint, the innovative new medium, was used to be stored in. And although it was painted well after the introduction of these paint tubes, these bladders remained relatively cheap and popular, in fact, quite late into the 1800s. Now, Cennini's got strong opinions when it comes to processing the pigment. He says, to work it up properly, take a slab of red porphyry, which is a strong and solid stone, for there are various kinds of slabs for grinding colours, such as porphyry, serpentinite, and marble. Serpentine is a soft stone and isn't good. Marble still worse, for it's too soft. But porphyry is best of all, and it will be better if you could get one of those which is not so very much polished and a foot or more in width and square. Then get a stone to hold in your hand, also of porphyry, flat underneath, and rounded on top in the shape of a porringer and smaller than a porringer. Shaped so that your hand may be able to guide it readily and to move it this way and that at will. Then take a portion of this black or any other colour, the size of a nut, put it on this stone, and with the one which you hold in your hand, crush the black up thoroughly. Then take some clear river water or fountain or well water. Grind this black for the space of half an hour, or as long as you like. But know that if you were to work it up for a year, it would be so much the blacker and better colour. So the longer you grind away at it, the better the quality of the pigment. I know I could have said that in 5 seconds and saved 45 seconds by reading it out, but there we go. Well, before the pigment could be applied to the wooden board or the canvas or the sculpture or whatever surface it's going to be, the the surface has to be prepared to receive it. It's just like painting the walls of your house at home. And this usually involved applying a surface coat of gesso, a word derived from the Italian for gypsum. And this permanent absorbent primer comprised of a mixture of a binder, which was usually rabbit skin glue, and ground chalk and/or gypsum. And this gave a white or off-white colour, which acted as a good, excellent ground or base to receive any medium of paint that you wanted to apply, tempera, watercolour, oil, whatever it might be. And now, you might think at last, let's get on to some pigments, although we've had a bit of geology even in the preamble. So we've got to think initially of the simplest pigments, the earth pigments or ochres. Well, this is a family of natural clay earth pigments which come in a variety of colours depending on their mineralogy. As you can see, the different colours are produced by varying amounts of 3 different minerals in the mix. They're all iron oxides: limonite, hematite and goethite. Smaller contaminants of ilmenite might add a different colour into the mix as well. So those are the minerals. If we remind ourselves what they look like a bit, all of them are weathering products, though hematite and goethite also occur as precipitates and form occasional ore bodies. Although listed in the table, not listed in the table, the streaks of these minerals are what are crucial. They give us the clues as to their possible uses as pigments. Hematite, of course, is one of the first things you learn when you go to any geology class, is that hematite has a cherry red streak. I can almost see you imagining the phrase in your brain. Goethite is brown and limonite is yellow. Limonite usually forms from the hydration of hematite and magnetite. It's usually slightly hydrated. And goethite usually forms at the oxidation zone in the soil and is associated with a change in state of iron cations from ferrous to ferric iron. So what were these used for? Well, one of the most classic and instantly recognizable uses of the hematite-based pigment red ochre is from the famous Le Chauvet cave in the Ardèche in southeastern France. This was discovered in 1994 and is now a UNESCO World Heritage Site. And the cave seems to have been occupied during Aurignacian and Gravettian times. That's late Paleolithic to early Mesolithic, if I remember rightly. And the famous artwork that adorns its wall is believed to be about 32,000 years old. And this is the famous handprint. The painter was probably left-handed, since the print is of the right hand laid on the rock wall. And the red ochre was mixed either with blood or saliva and probably spat over the hand using the hand as a stencil from a tube probably held in the mouth to yield this scarlet silhouette. In fact, the hand is not alone. There's a whole constellation of them that greeted the cavers when they first broke into the cave system. And indeed, this cave system contains over 400 handprints, as well as renderings of mammoths and other local fauna. And it's even been suggested that this might be part of a rendition of a volcanic eruption. Well, you could see the pyroclastics there. Whether that's truly volcanic or not, I wouldn't like to say. Red ochre might have been used by Homo erectus as much as 1.5 million years ago, and certainly by Neanderthal man 250,000 years ago. By 100,000 before Christ, ochre was being used widely, with the centres being set up to receive excavated ore for processing and subsequent trading. You may have come across this cave, Blombos Cave, found in the coastal cliffs 200 miles east of Cape Town in South Africa, discovered in 1991, and it records something of the fascinating details concerning the history of the use of red ochre. Amongst the remains there are 2 pallets made up of abalone shells for mixing the red ochre paint in. And there's a whole series of rocks which have got stripes like this of red ochre painted on them. You might argue that this is some of the earliest abstract art. And here we've got some with incised markings there, which were enhanced with hematite pigments as well. And at Lascaux, again, a place that some of you might have visited, we've got these a whole variety of animals illustrated in the Dordogne here. The cave contains nearly 6,000 figures with a whole host of different animals depicted in ochre colours. There's some more there. Ochre was the most commonly used pigment for painting walls in the ancient Mediterranean world. And on the right, we've got ochre paintings in the tomb of Nakht in ancient Egypt, dating from the 15th century BC. Yellow was associated with gold, which was considered to be an eternal and indestructible material. And the skin and bones of the gods were believed to be made of gold. So often the Egyptians would paint their gods in this gold, sort of yellowish ochre. And on the left, we got the fresco of a Roman villa still preserved under a covering of pyroclastic rocks before it was excavated from the eruption of Vesuvius, destroying Pompeii and Herculaneum, of course, famously in 79, was it 79 AD? Thereabouts, anyway. In classical antiquity, the finest red ochre came from the Greek colony in Cappadocia on the Black Sea, the site of the modern city of Sinop in Turkey. And it was carefully regulated, expensive, and marked by a special seal, and called, therefore, sealed Sinope. Later, the Latin and Italian name Sinopia was given to the wide range of dark red ochre pigments. And shaped into sticks with knives, hematite or red ochre chalks were used for drawing, sometimes to give an outline which would later be painted over. And natural red chalks with their rich, warm colours were popular from about 1500 to 1900. And artists such as Michelangelo, Rembrandt and Watteau used this medium to produce some of the most coveted drawings in the world today. But by the 18th century, synthetic red iron oxide pigments were being produced, so hematite and limonite and the others tended to go the way of all flesh. Perhaps one of the most famous earth pigments or ochres was sienna, from the Italian terra, de Siena, meaning the earth of Siena. It contains iron oxides and manganese oxides and is also referred to as terra rossa, or just red earth. Terra gialla is yellow earth, and in its natural state, it's got this sort of yellowish brown color, and it's called raw sienna. But when you heat it, it becomes a reddish brown because of the loss of the volatiles, and it's called burnt sienna. So those are some of the names that we had from our childhood watercolor palettes before. And in fact, I received an email today from the National Gallery. They've got an exhibition coming up on sienna in the spring. Just to keep your eyes open. Well, in the Middle Ages, the sienna pigments were used by artists, especially local ones, like Duccio da Buonantenia and other painters who lived and worked in the area or in the Republic of Siena. Duccio was painting with earth pigments in the late 13th century until his death in the early 14th. And he was hired throughout his life to complete many important works in government and religious buildings around Italy. And his extensive use of siennas can be seen in those examples of his work. Well, Renaissance painters continued to use these earth pigments, and in 1299, the commune and people of Florence decided to build a palace that would be worthy of the city's importance and that would be more secure and defensible in times of turbulence. So the Palazzo Vecchio, or Old Town Hall, contains the Hall of the 500, the largest hall in Italy by volume, built in 1496 and later extended by Giorgio Vasari. The walls and the ceilings were covered in frescoes painted by Vasari and his various assistants. And these are dominated by the light tones of the earth pigments, including a range of ochres and terra rossa, and to very good effect. I think you must agree there. And in this particular self-portrait, Rembrandt used all of the earth pigments to produce an image which is rich in a series of brown colours. Yellow ochre was also a favourite pigment to use in order to produce a distinctive yellow that was used to represent the cowardice. And this cowardly yellow, as it was sometimes called, was specially used to depict the vestments of Judas Iscariot, who betrayed Christ, of course, for 30 pieces of silver, as is shown here. And unfortunately, not only is he wearing yellow, but he's got some sort of form of hydrocephalus. If you look at the shape of his skull, he's entirely unnatural. And it appears here with a much more normally proportioned skull in Holbein's image, Bondoni's image of the Kiss of Judah. Okay, on to the colour green. So a number of pigments provided this colour, but only two have got geological origins. That's malachite and what's called terre verte. Quite a vibrant green is the one named verdigris there, which of course is just basically a copper acetate. If you put vinegar on copper, it gives you this verdigris color, which in some countries, of course, is used to color the copper sheathing on the tops of roofs. You go to Copenhagen, for example, there's lots of wonderful verdigris roofs on the buildings there. Well, malachite green is probably the most ancient of the green pigments and was used in Egyptian paintings in various tombs, especially for vegetation, as you can see here, or in this boat and the various beasts on either side. And I'm sure you're all very aware of the mineral itself. It's a copper carbonate, hydrated copper carbonate, and you've probably got some in your mineral collection because it's just such a wonderful color. Often found together with azurite and chrysocolla, primarily as a supergene enrichment and oxidation of primary copper ores. Historically important sources included the Carpathian Mountains and the Isthmus of Suez and Sinai during the time up to about 4000 BC. Well, George Agricola described the mining of malachite in the Carpathian and Harz Mountains in his famous mining manual, De Re Metallica, of 1546. And he noted that the malachite-laden water resulting from the reaction with copper ore deposits, if you passed it through a series of graded sluices like this, you could precipitate out fine grains of malachite, which could then be used as your artist's pigment. And preparation was quite complex. You had to grind it up, wash it through several cycles, dry it, and intensify the color in this sort of procedure. Well, malachite green was a popular pigment during the Renaissance, and Giotto used it in the early 14th century, I beg your pardon, to color the robes of the Madonna as she held again a rather peculiarly proportioned Christ child. It looks like a tiny adult with enormous forearms. It's sort of, sorry, I shouldn't be in church maligning a vision of Christ, but it looks a bit like the Incredible Hulk, or Popeye, those forearms. You can tell I'm a Philistine, can't you? This continued well into the 15th century when Verrocchio also used it for the robes of the Madonna. I think I've labeled it, yeah. But it doesn't look like the green you would expect from malachite, does it? That's because it's discolored because the medium that was used was this egg tempura. The egg yolk's gone off and has given us this peculiar color to the green. And this example shows its use by Raphael in the early 16th century. Commissioned by Pope Julius II in 1512, this portrays the Madonna holding the baby Christ, a much better proportioned one this time, standing on the clouds and flanked by St. Sixtus and St. Barbara, and interesting for us in that she's the patron saint of miners. And two distinctive winged cherubs, the putti, sit on their elbows beneath her, and the heavenly association of malachite is retained in the sashes of the curtains, that they're being pulled aside to reveal this heavenly scene, and the coloured sash around St. Barbara. And again, we've got use of a much paler malachite green in this painting from the National Gallery. Well, you're probably less likely to have come across celadonite, which is a microgroup phyllosilicate mineral, basically is a clay mineral under any other name. And it was used in these sort of aggregates in order to produce a sort of washed out green color. Probably more, well, yes, I mean, you're almost living on the green sand. So that must be familiar to you, the glauconite, again, which was used to produce a green color. And in fact, this is glauconite, a glauconite terre verte, produced here for extensive use in these frescoes in the House of Livia in Italy, and a close-up of the trees that are portrayed there. And a little later, these green earths were still being used in substantial frescoes, such as here in this ancient church from the 1100s in France. And although it's a useful color, the green earths lack the intensity of most other greens, but were quite good to be used in Middle Ages and Renaissance, especially as underpainting. So you could paint the underneath of the robes, let's say, in a terre verte, and then overpaint it with malachite to intensify the green color. They've also been found in the Friedrich Helen's extensive multi-paneled altarpiece in the Church of St. Jakob in Rothenburg, believed to have been made between 1462 and 1465. And in this panel, they appear to have formed the basis of several green garments. And then Michelangelo's unfinished Virgin and Child with St. John and the Angels, popularly known as the Manchester Madonna, because that's where it's held, from 1497, shows that an underpainting of green earths is visible on the left-hand side in this unfinished painting. And the reason he did that was to achieve realistic flesh tones. Because if you used sort of a rose color for literally for rosy cheeks, then you would get all sorts of weird colors developing. But if you underpainted with green, it allowed you to produce the flesh tones without any problem. And if you look here, these very jaundiced, sickly looking people in the Annunciation have the rosy cheeks have faded, so to speak, to show the terre verte underpainting that was used in order to give you the flesh tones in the first place. And of course, as you'd expect, these greens are very useful a little bit later on in the 17th century for pastoral scenes. And in this particular one, for the greengrocer, green being the operative name here. And also here in this painting by Vermeer, a girl reading a letter at an open window. You've got the sashes there. Now, if you remember nothing else from this lecture, I want to give you a good tip as to how to identify an artist, and that is Vermeer. Nearly every time he painted a picture, it was somebody sat in front of an open window, or a closed window for that matter, for some reason or other. We'll come across him again a little bit later on. Here he is again. This time we've got terre verte. Oops, I thought I had an arrow, I didn't. Being used as a painting material there, and again she stood in front of a window. And this final, did I label that one? Yes, I did. This final painting shows the use of the two pigments, the terre verte or the celadonite or glauconite or whatever, in the background for the hills, and for the richer color of the robes that we're using malachite. So onto the blues. And as before, there are only a couple of blue pigments which are mineral based, and those are azurite and ultramarine. And azurite is a hydrated copper carbonate, easily confused, I have to say, with the lazurite that forms the core of lapis lazuli. And it's often occurs with malachite and is used to give a good blue color. Again, it has to go through a whole series of operations in order to concentrate the material, but that done so, when you paint with it, you get good blue colors, but unfortunately, again, they tend to fade because of the action of sunlight and oxygen on the egg tempera. Here we are, got the same sort of thing, look, darkening of the robes of this azurite mantle. And here we've got the azurite turning almost green there. You'd be forgiven for thinking that it was a terre verte or malachite green in those positions. But those that remain fairly stable, this very famous painting, the lady with the squirrel and the starling in the National Gallery, has got an azurite background. And the Albert Altdorfer in this painting here is using extensive work with azurite in the blue color of the skies, and again in the robes of the Madonna and other people here. And here we've gone for a 9-foot tall Jesus instead of, it's amazing really. And if you vary the grain size, you get different colors of blue. So the finest grazed azurite, which is fairly coarse, the finest grade, I can't say, finest grade. So that's a slightly coarser grain side give you a darker blue, and a lighter blue is obtained by using a finer grain size. So moving on, we've got lazurite, which of course is part of the rock type lapis lazuli. And you're reminded that I did talk to you before about lapis lazuli before, and it's mined in these adits in the sheer mountain slopes of Afghanistan, and then you've got to take it home, so you do it on your back, and then you've got to process the material, because in it there's all sorts of other minerals that you don't want involved in the pigment. You can see the sparkly bits there, that's pyrite. There's also a lot of calcite in there. So what you do is you crush it to a powder, allow it to dry, and you end up with this sort of color. But then if you put hot Venice turpentine over it, mastic and beeswax, mix it all together, you get this sort of squidgy mass, which then you can allow to soak in water or a lye, and the minerals begin to separate out. The hydrophilic parts begin to separate from the pyrite and the other minerals. That gives you your intense blue color of pigment like you've got there. Giannini, of course, had something to say about this. He said, ultramarine blue is a color illustrious, beautiful, the most perfect. Beyond all other colors, one could not say anything about it or do anything with it that its quality would not still surpass. And it was used just off the Silk Road in the Thousand Buddha Caves. This is about 80 kilometers off the Silk Road. These early Buddhist paintings depict the various stages in the life and adventures in the life of the Buddha. And it's all using lazurite as the blue material for the background. But it was also coming to this country and could be used in miniatures, for example. So we've got the Aberdeen bestiary on the left here, and the ultramarine blue is being used for the raiments, and on the Book of Hours over there. And it goes very well with the gold, I must say, that it sort of counterpoints it. And in this early surgical text, it's used again to show the background of these very unfortunate people. No wonder he's throwing his hands up in the air. I mean, he's got a spear and an arrow sticking out of his abdomen and his chest. Goodness knows what's going on with this chap. And then the famous Wilton diptych. Again, it's basically painted with using lazurite as the intense blue color. And Titian was living in an area that was easy to intercept the imports of lazurite, ultramarine from Afghanistan. So he was sort of had first dibs on it in some ways, and he used it extensively in the sky and in the raiment, sometimes underpainting with azurite, so that he didn't have to use quite so much lazurite. And here we are, the girl with a pearl earring, famous picture. It's Vermeer again. Now notice here, no window, but look at the lighting. The window's just off over to the side here, and the light's falling from the window onto her face. Again, painted in ultramarine, and back to her lady standing at the virginal, again, painted with ultramarine. And this beautifully restored image in the National Gallery, we've got the sort of intense blue color that this pigment would produce when it was sort of pristine. Onto red. And the red colors, again, it's two: vermilion and red ochre. Now, we've seen red ochre before, so we won't sort of dwell on that one. I just mentioned rose madder because that's made from a plant, the madder plant. The roots are used there. So vermilion comes from a mercuric sulfide mineral, basically cinnabar, and which has got this sort of correct streak. And it was used very early on in wall paintings. Here, for example, in Çatalhöyük in modern Turkey, 7,000 or 8,000 BC. And to produce an image, it's believed of the earliest image of a volcanic eruption that nobody's really sort of arguing about, with the town at the foot here, and Hasan Dag, I think it is the volcano in the background. It was also used to enhance the oracle bones of the Chinese. Oracle bones were ox scapulae and turtle bones and things which had engravings on them, which had magical formulae and all sorts of stuff. And in order to pick out the scratch marks, vermilion was rubbed into the surface. It was also used to color Chinese lacquerware. So that basically it's ground up cinnabar mixed in with resin and then molded into these shapes. And here in Pompeii, we've got abundant use of vermilion on the walls of the Villa of Mysteries, used before 79 AD. But probably the most extensive use is in Palenque in Mexico, at the tomb of the Red Queen, so called because everything is smothered in red. There's a tomb just over there on the bottom right, and you can see the residue of the vermilion pigment there. It's used in painting some of the wall materials, as you can see here, but she herself was absolutely smothered in vermilion pigment for reasons we know not, or at least I know not. Anyway, I thought you might be interested in this. This is her death mask, which has got a few other minerals associated with it. Limestone for the whites of the eyes, obsidian for the pupils, tesserae of malachite to form the face, and jadeite for the necklace around the neck. Vermilion was also used to highlight certain words and phrases in illuminated manuscripts and missals and things like that. So this one is from the 12th century, and as well as vermilion, orpiment, the arsenic sulfide, is being used there to give us sort of an orangey color. And here again, vermilion is being used to underline, highlight certain words, and also in the robes of the people in this illustration. And here we are, the robes of the Virgin Mary. So she's gone through quite a lot of changes. I mean, she's been done in green, she's been done in blue and red, and we got vermilion here. And again, on this one here by Titian. And in this case, somebody helping Jesus down from the cross, we've got vermilion used in his robes. And finally, as a base with a special coloured glaze to bring out the red colour, a cochineal glaze. I'm sure you've come across cochineal. Cochineal is a tiny scale insect that infests prickly pear, and when you crush it up, it yields this intense red colour that was commonly a food colouring. In fact, it's still called cochineal. I'm not sure whether it still requires mashed up beetles or whether there's a synthetic component in there, but that was used. Onto orange. In this time, we've got orpiment and real jar. Both of them are mineral pigments. Notice saffron. In the Middle Ages, we used to be the world's biggest producer of saffron in East Anglia and South Yorkshire. And this, in addition to the sort of spice of saffron, it was used to produce this orange colouring. But the two minerals we're looking at are basically the same thing. They've just got different proportions of arsenic versus sulfur and give you the orange versus the red colour. And they come mostly as sublimates from fumaroles, like at Solfatara. And the orange colour of orpiment in particular is very easy to spot. And remember what I told you about the bones being gold for the various Egyptian gods. Well, it was the colour of choice then to decorate the bust of Nefertiti here, for example, and other dignitaries. And in this particular papyrus, it's used as a material to give that colour to the images. In this instance, we've got a peculiar reaction taking place. We've got orpiment being used, which should give you a sort of a yellow colour. Real jar gives you a reddish colour, but there tends to be a reaction between the two, giving you what's known as parareal jar. And that gives you all sorts of strange coloured intermediates. So it can be quite difficult to tell quite what's what when we've got rather old images like this one. In this instance, we've got orpiment being used to give you the brown colour on the raiments of this particular shepherd. And here we've got a mixture of orpiment and realgar being used in these vestments on this character, and also the same here. And here as well, we've got yellow earth and orpiment mixed together, basically to give you a different shade. So this brings us to our last group using gold and silver. I need to mention our Armenian bowl. That's basically a fossilized earth that comes initially from Armenia, although Armenian bowl comes from lots of places other than Armenia. It was used medicinally, but it's also quite important to use as a ground under the gold so that the gold had something to sit on and stick to the canvas or whatever it was you were using. Now, I'm sure we're all used to native minerals, gold and silver. And the gold here, for example, used in the printing, or the calligraphy, I should say, of this version of the Quran, shows out beautifully against the background. And there's a form of use of gold paint Now, this is gold paint based upon gold flecks in suspension called chrysography. And it was used to highlight the capitals, for example, in many manuscripts. But mostly the gold was hammered flat to form very fine flattened filaments, only about a micron thick. This is an image of a gold leaf worker. And then the gold leaf would be applied onto the manuscript, very specially, sometimes laid on top of a layer of water evacuated so that the gold leaf would rest on the top, then painted over to make it with a brush to make it settle, and then finally burnished, brightened up by rubbing a wolf tooth over the surface of it to give it a nice flat surface. And they were sometimes called shell gold and shell silver because they were mixed up in scallop shells, and this finely ground sort of tailings from the gold industry would be mixed with a medium to allow it then to be painted onto these surfaces. So here we are, we've got some icons. This is where gold has probably been used most sumptuously and as a background. And the important thing that we got here is not just the fact that there's gold leaf on the back of it, but the gold leaf has been tooled in a very special artisanal way to give you distinctive patterns, especially you can see there, look, in order to bring out the foreground. And that's a technique that took place in all sorts of cultures, not just in the Eastern Orthodox, but here, for example, a 1590 screen, all the background is basically gold leaf in squares there. So what we've seen this evening then is the use of a whole range of mineralogical pigments: chalk, graphite, limonite, hematite, goethite, malachite, celadonite, glauconite, azurite, lazurite, vermilion, orpiment, real jar gold and silver, plus a few others as accessories: gypsum to give you the gesso in order to act as a ground for the paint to come on, and then drying agents: litharge, massicot, allanite, goslarite and pumice. So now comes the test. I did spend my life as a school teacher, so I'm used to flying objects, I might add as well. So here, what might we expect? I mean, so for example, the green there, what is likely to be the case? Malachite. Malachite is a good guess. It's a bit more intense than perhaps the terre verte that we might otherwise expect. And what about in the background of the sky? Azurite. Azurite's probably more likely than lazurite, isn't it? The lapis lazuli or ultramarine, again, because it's a bit of a washy blue, not a really intense blue. And what about the red cloak there? I didn't hear that, sorry, I heard blah, 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 blah. Vermilion, absolutely, vermilion. I'll just end with this huge 8-mile-long canvas, inverted commas, with Ice Age drawings of giant sloths and so on, survived in the Amazon rainforest for 12,600 years using a series of ochres that's just recently been uncovered. Thank you.